Mhm.
Yes.
Yeah, okay. Um, okay, so today's topic will be about it is basically industrial application of AI. What happens is in industries we have some electrical machines, or in factories we have some kind of machines. So what happens is there will be some load when we talk about some let's say some electricity power supply substation, or we have some a factory where there is some load which has to be supplied. It can be anything, or some manufacturing plant where some output is expected at the end of day. So these kind of plants which has physical machines, they need a regular maintenance of their machine. So if it is a physical machine, it will need some sort of maintenance. Sometimes what happens is the machine might break down due to some reason. Reason can be anything, it can be if there is too much of cold, then there are chances of tearing down of some part of the machine. If there is too much of high temperature, so I'm talking about temperature scenarios, that affects a lot. If there is let's say there is some rotating machine, and due to some if that machine is running from so long, like let's say 2 years or 3 years, so we after some time there are chances that the machine will not be in the condition uh, it was in when it was bought. So when the machine is new, after some time it is, let's say, a rotating machine. It will rotate, and even winds or weather conditions or something will keep on degrading its performance, or it will slow down after some time. So such a situation happens, and this and sometimes these operations are too critical, that what happens is if a machine breakdowns, it will lead in basically an outage to what the plant is serving. It can be anything, if we talk about railways, if the track goes off, it will block the route of the train. If there is a oil gas plant there, if something goes out, then it's a direct impact to the customers. So for this purpose, like, machine should not break down. What industries does is they have some planned interval. Let's say I bought for example, I bought a machine today, and I'll get a manual which is from the manufacturer, which will tell me when this machine has to be maintained. When there will be a fixed interval, like 6 monthly, quarterly. Then there will be a maintenance person going to that particular machine and checking everything in the sense whether the base material of the machine is breaking, whether the machine is producing right output, what is the input supplied to the machine, or in case any input is required, if there is any gap, or for example, initially a machine, or let's say a generator or a motor, used to produce a certain amount of output in let's say motor speed. So by the time motor speed with the time motor speed is decreasing, so if it is decreasing with time, that means my machine requires a maintenance. It can be in any form at this, in the sense maybe there is an oil change required. Maybe the base of the machine is broken, or maybe the mount point where the machine is fixed, screws are loose. I need to tighten them up. So all these activities comes into the maintenance. So what happens is this machine factories maintenance is is like continuous and it is required always. So it caters to some sort of cost. So what happens is there will be a manual always with the machine saying that you need to maintain your machine in these sort of intervals, which is based on the manufacturer experience and the users who are using that machine. And it is basically an average time or the best time where a person should maintain its machine, but it is not the best time for the person who are actually using that machine. So every plant or industry will have its own criteria or weather conditions or load capacity on which it is working, and the average maintenance time will always not match with what actually is required. So there is some cost connected, and there are some outage windows. So let's say I want to maintain some machine, I need to switch it off and do some planned maintenance, like I need to check the oil, I need to check the output. So these all things also takes some outage window, that machine will be unavailable for this point of time. So from this predictive maintenance, what we are trying to achieve is we will be having a series of data connected. Let's say I'll run my machine from the very healthy condition to the condition where it is teared down or completely collapsed. I'll keep on taking all the readings. Let's say, for example, I have a motor. Motor is giving full, let's say 100% output. Then it kept on degrading after some time, and at a point it collapsed. The coil or the winding of the motor completely burnt out. So all these situations, for all what all things are taken care in motor is what is the current supplied to this motor, how much whether there is in turn shorts are there in the motor coil, or like this there will be set of parameters which will be there, and I'll be noting down on the series of time that what happens if this parameter changed, what is the expected output, and these gathering of features and data collection will lead me to a solid plan, like this is the current useful life which is pending for my machine, like this much of time it will be healthy, and then after this point of time it will need a maintenance, and what is the exact maintenance it needs, whether it is a breaking of that bearing, whether conductors are shorted, whether oil is less, whether air gap in the motor is bad. So these kind of things, what I am doing is, instead of doing preventive maintenance on the fixed interval of time, I am doing a predictive maintenance, which is done only when it is required. Not 6 months, not quarterly, but just before when it is required. This will reduce the cost of operation, like maintenance and outages have this thing, what we call, have some cost associated with them, and regular planned maintenance will not have like actual situation, like this machine will go out, and it is better to do some cures before the machine is completely collapsed, because replacing the machine completely is a costly action than making it fixed. So this is all about predictive maintenance we'll be talking about. So yeah, so it's cost saving over routine or time based preventive maintenance. So what is predictive maintenance? So predictive maintenance techniques are designed to help determine the condition of in-service equipment. So in order to estimate when maintenance should be performed. So this approach promises cost saving over routine or time-based preventive maintenance. Because tasks are performed only when warranted, Thus, it is regarded as a condition-based maintenance carried out as suggested by the estimations of degradation state of the item. Now, as I said, there will be a set of parameters which are recorded. These parameters will be different for different sort of machine. Let's say for a railway track, it will be one of the parameter will be the gap between the track and this thing, the ground. So, if I have a void, the void will tend to block this thing. That track might go out of use for some time and won't be able to use that track at all. So every scenario of a predictive maintenance has some set of parameters that has to be decided with a data scientist. Let's say there will be a data scientist, but there is a domain expert who is required. If I want to do a predictive maintenance of a induction motor, I need a domain expert for a induction motor to give insight to the data scientist that these are the parameters which may affect the machine. Like if I have these all things set, these are the output conditions. Parameters can be anything. It can be visual. It can be heard output. It can be electrical signals. It can be some ultrasound signals. So, So how does basically predictive maintenance work? So I was talking about this predictive maintenance needs a complete involvement of a data scientist as well as a domain expert. So domain expert has to tell the data scientist that you extract these features and these can be converted to this one outputs. So how does it work? So this predictive maintenance uses condition monitoring equipment to evaluate an asset's performance in real time. Now the key element in this process is IoT device. Now the IoT device allows different assets and system to connect, work together and share, analyze the data action. Now what happens is IoT relies on predictive maintenance sensors to capture information, make sense of it and identify any areas that need attention. Now some of the example of predictive maintenance and predictive maintenance sensors include some vibration analysis, oil analysis, thermal imaging and equipment observation. So to check the vibration, for example on a motor itself there are some flat points and a meter will be there and a person has to go in person to check the vibration if they are beyond some point. So these all equipments can be fitted over a machine and can be taken as a regular input instead of taking input weekly, monthly. The inputs are automatically taken. When they are taken, when they we need not stop the machine to take any reading. Readings are taken in real time, and the same flags and alerts can be generated for the maintenance persons in real time instead of doing it on a fixed interval. So yeah, thermal imaging can be one of the sensor which can we can put. So this is how it works. Now, what's the goal of condition-based maintenance? The goal of condition-based maintenance is to monitor and spot upcoming equipment failures. So maintenance can be proactively scheduled when it is needed. So not before that. Maintenance is done only when it is required, not before and not after it is completely collapsed. So asset condition need to trigger maintenance within a long enough time period before the failure. Now, as it is not preventive, but it is predictive maintenance, so my system will predict that this is your machine has a useful life of, let's say, 3 weeks, and you need to go and do the maintenance now itself to avoid any failure after 3 weeks. So work can be finished before all the assets or performance falls below the optimum. So it's a red flag which is given to the maintenance guys that this is the this much of time only your equipment will work fine, but after this point this will collapse. So maintenance person can go and check it, replace it before it is collapsed, or they're saving the cost as well. So yeah. So there are some advantages as well as disadvantages for this condition based monitoring. Like the advantages are like CBM means condition based monitoring is performed while asset is working, which lessens the chance of disruption of the normal operation. As I said, no need to stop the machine. These are the sensors which are fit over the machine itself and take the readings in real time, like take the observations in real time, so that we need not shut down the machine or no outages are required. It reduces the cost of asset failure. So it's always better to fix a machine rather than replace the machine completely, because we have some household equipments. Those are not much costly, but industrial equipments are very costly, and replacing them takes money, takes time. So if I order some equipment now, it might take some months of time to come, and till then my customers will be on hold. So it doesn't happen like that. Like industries has their backup machines, but what if backup machines are also free? Then it will take money. It will take time. So minimizing the time spent on maintenance. So if I'm doing regular maintenance, let's say 1 week, 1 month, quarterly, half yearly. So and even when maintenance is not even required, so it's wastage of time and money. So minimizes overtime cost by scheduling the activities. Minimize requirement for emergency spare parts. So if my machine is broken down, there will be some emergency spare parts which will be required. Then optimizes the maintenance intervals, more optimal than manufacturer recommendation. As I said, there will be a recommended time interval. There will be a checklist which will be there for the regular maintenance. Like if I go for weekly maintenance, I need to check the oil in the machine. If I go for half yearly maintenance, I need to check the base on which the machine is what we say fixed. I need to check the bolts, whether it is like whether bolt like screws and all those things are loose or not. So these kind of checklist and some recommended things will come from the manufacturer, but those are not the exact to your use case. Might be those are as per manufacturer experience from the years from when people are using it. It will be an average time where it should be tested, not the exact time as per your operating conditions. Improper worker improves worker safety, reduces chance of collateral damage to the system. Now, if a person is going in personal to check the machine, so it is somehow affecting their safety also. In like instead we have some sensors fit there, and those are only checking things for me in real time. So yeah, there are some disadvantages as well. So condition monitoring test equipment is expensive to install. What happens is if I'm fitting, let's say I have some 400 induction motors in some plant. So I will have to fit sensor to each of the induction motor to take readings in real time. So sensors will not be a single sensor or two sensors, there will be multiple. There will be, for example, some infrared imaging happening. There will be some vibration analysis happening. There will be some electrical outputs. Like I need to take current readings as well. Let's say what is the input current, what is the output power, and all those things. So these all sensors has to be fit to every machine, and then setup cost is more, database cost is more since I am storing a huge data. So this is one of the disadvantage. Like setup cost is more, but and this cannot be applied to each and every instrument. So there will be a plant. I need to identify my mission critical equipment out of that plant, and then only I will install these devices only. So next is cost to train the staff. You need a knowledgeable professional to analyze the data and perform the work. Now, what happens is if all these sensors are fit, IoT devices are there. So these sensors will give output to the IoT devices, and these IoT devices to be like more readable, you need a professional staff which has some experience on taking readings and coming to some conclusion. So there is a cost involved to train the staff and make them ready for this technology. Then fatigue or uniform wear failures are not easily detected with the CBM measurement. So as I said, it is purely based on sensors which we fit. So sometimes what happen is a machine is running from quite a long and it needs to shut down for some time. Maybe there will be some what we say fatigue happening in the machine which needs to be addressed, and that can only be seen or identify the human or the maintenance guy when he visits that location in person. So there will be some sort of criteria or some process to identify that, but that has to be identified. So as I said, there should be a domain expert. There is a domain expert required. There is a data scientist. Domain expert has to give all the information, like what all things are affected, what all features has to be extracted in order to do this predictive maintenance. Data scientist could not alone do this thing. Yeah, until unless he is the domain expert. So condition sensors may not survive in operating environment. So there are this is a kind of scenario which is not true for all the things, like true for all the environments. But sometimes it is true. Like there are sensors which are not which cannot survive in that environment. So let's say I have a boiler or some critical instrument which has some high temperature processing, uh, uh, which has some high temperature processing task. So that environment is not suitable for my sensors to put in. So yeah, this and may require asset modification to retrofit the system with sensors and unpredictable maintenance period. Now, since I have all the maintenance, like all the readings in real time over the time, and I have a huge data, now I will preventive maintenance is like there will be a weekly maintenance, there will be a monthly, and there will be quarterly, there will be fine. So I am well prepared that yeah, this maintenance is coming. But for this predictive maintenance, anytime let's say my load increased, my machine teared down, and not teared down completely, but the useful life of my machine has decreased. So that will induce some unpredictable maintenance period. But in other hand, advantage is that unpredictable maintenance period is identified and will be addressed before the machine has taken down completely. Yeah. So, example of condition-based maintenance. Motor vehicles come with a manufacturer recommended interval for oil replacement. These intervals are based on manufacturer's analysis, years of performance data, and experience. However, this interval is based on an average but best guess rather than the actual condition of the oil in any specific vehicle. Now, the idea behind the condition-based maintenance is to replace the oil only when the replacement is needed and not at a predetermined schedule. Now, in the example of industrial equipment, oil analysis can perform an additional function too. So, by looking at the type, size, shape of the metal particulates in that are suspended in the oil, the health of the equipment it is lubricating can be determined. So, let's say my copper wires or something is has are facing some corrosion thing. So there will be some lubricants there. I can test that oil, and based on the content that or the materials those are infused in that oil, health of my machine can be identified. So this is purely based on domain knowledge in the sense, if I'm talking about induction motor, an expert for the induction motor is required. If I'm talking about the railway tracks, an expert for those tracks has to be involved and give me proper data points that these has to be collected from the equipment. Yeah. Then types of condition-based maintenance. So these are few types. There can be more based on domain. So there will be oil analysis, some infrared. Infrared is like thermal or IR imaging will be there. Then there will be some electrical parameters. So I might need to. So ammeter is an instrument to check the current in the machine. Voltmeter for the voltages in the machine. So there will be some electrical parameters like current, some power input, and mechanical output. So like that, some parameters will be there. Those can be done. Then operational performance. So how my machine is performing. So there will be some set of parameters to do. Some like ultrasonic. Ultrasonic will be useful in let's say a boat machine maybe. And then acoustic. So some things like a machine is loose or there is some leakage can be only seen and found out. So those comes under acoustic maintenance thing. And the vibration analysis. So if in vibration analysis, I take example of a motor itself. Motor has a rotor element and there is some air gap. So if there is a disbalance in the rotor and the stator, like if the rotating part and the static part, there is some misbalance in the alignment itself, the machine will tend to produce more vibration or less vibration, more vibrations. So more vibration might be a sign of machine performance down or misalignment of the rotor element. So these are some examples of what all maintenance points we can take into consideration. There can be more purely based on the domain. Yeah. So these are the various type of few examples, common examples which are used. The same in the previous slides. There is some text in front of it. Like vibration analysis is like rotating elements like compressor, pump, motor. They have some certain degree of vibration. As they degrade or fall out of alignment, the amount of vibration increases, and the vibration sensors can be used to detect when this becomes excess. Then there will be infrared, IR cameras can be used to detect high temperature conditions in energized equipment. Ultrasonic detection of deep subsurface defects such as boat hull corrosion. So deep surface like detections in deep surfaces can be detected using ultrasonic things. Then acoustic, so used to detect gas, liquid, vacuum leaks. Then oil analysis measures the number of and size of particles in sample to determine asset wear. So oil analysis is like we have sample oil. I check all the components which are infused inside it, and then do it. Then electrical, like motor current readings using clamps or ammeter. Then operational performance. So sensors throughout the system measures pressure, temperature, flow, etc. So challenges of condition maintenance. So condition-based maintenance has some challenges, like it requires an investment in measuring equipment, and the staff has to be upskilled. So the initial cost of the implementation is very high. Condition-based monitoring introduces new maintenance techniques which can be difficult to implement due to resistance within organization. So, as in factories or industries, people are used to see the old method of doing things. So there will be some sort of resistance from them as well, that why should we adopt this, even we are getting so high, like this much high cost we have to pay to install this kind of equipment, and you need to upskill all your labor as well. So some sort of resistance will come within the organization. Old can be difficult. The modern and what happens is, nowadays equipments are manufactured keeping in view that some sort of monitoring equipment and the sensors will be fit over it. So, but older generation equipment, it is difficult to fit all these sensors and monitoring equipment on the spot to measure during the production. Now, with condition-based monitoring in place, it is still competence to turn performance information from a system into actionable proactive maintenance items. So it is challenging. It will not be possible without a domain expertise to predict what actual thing I have to take out of the machine in order to get the right prediction. So if I don't know my induction motor, how it works, what all the losses involved in it, and how much input leads to the, like how much load leads to the breakdown of the machine. I don't know all those parameters, then I cannot write a predictive maintenance. So first I'll have to study the complete equipment, what happens when I increase my current, what happens if let's say for example I have a 3-phase power, what happens if two of the powers are off. So all these things has to be coming from a domain expert, or I have to take a domain expertise in order to predict its maintenance. So these are the few challenges. Then yeah, in the end, costs, it has cost savings plus higher system reliability. So condition based monitoring allows preventive and corrective actions to be scheduled at optimal time, thus reducing total cost of ownership. Today, improvements in the technology are making it easier to gather, store, and analyze data for condition based monitoring. In particular, condition based monitoring is highly effective where safety and reliability is the paramount concern, such as aircraft industry, semiconductor. So, as I said, there it should be applied only to the mission critical instrument inside the complete plant, because as installation is expensive, I cannot put sensors on each and every element of the plant. I will have to pick out some critical devices and only has to put it there. Then only it will be cost effective. If I'm putting it anywhere, it will never be cost effective. It will be expensive only. Yeah. So there are some industries where safety and reliability is a paramount concern, such as aircraft industry, semiconductor manufacturing, nuclear, oil, gas, etc. Yeah. So what is predictive maintenance suitable for. So there are some suitable applications. So as I said, it is not like I'll put it anywhere, it will work out in cost effective manner. Applications that are suitable for predictive maintenance include those that have a critical operational function, have failure mode, and second point is they have some failure modes that can be cost effectively predicted with regular monitoring. So there should be some features or some dependent parameters which can be cost effectively detected. So for example, some parameters are like I can just go in person and see it. So implementing object detection camera, for example, maybe any expensive sensors there won't make any sense. So the machines which have some failure modes that can be cost effectively predicted with regular monitoring is suitable application. Now, what is unsuitable application? Unsuitable application for predictive maintenance include those that do not serve a critical function, that do not have a a mode that can be cost effectively predicted. So these are two critical points. So if I go ahead and check for all the equipments in the plant, what all equipments I need to consider for a predictive maintenance, I need to check whether it is a mission critical equipment. Second, whether there is some failure mode that can be cost effectively predicted. So these are the 2 points that has to be considered. Now, what the impact of predictive maintenance? Predictive maintenance seeks to define the best time to work on an asset, so maintenance frequency is as low as possible and reliability is as high as possible without unnecessary cost. Now, utilizing the Internet of Things is the key to implement a successful predictive maintenance program, as is the use of predictive maintenance sensors and techniques such as vibration analysis, oil analysis, thermal imaging, equipment observations. Although there are some disadvantages to predictive maintenance like high startup cost, the need of specialized skills, limitations of some equipments like some older like old generation equipments cannot be used. It allows maintenance to be performed only when required, helping facilities cut costs, save time, maximize resources. Consultation with the equipment manufacturer and condition monitoring expert should be undertaken before deciding that if predictive maintenance is best for the particular asset. So, domain expertise is always required in such cases. Like we need to talk to the manufacturers, experts. We need to consult them and check whether the equipment we are trying to use for this predictive maintenance is is the right or is suitable for the job or not. Yeah. So this is impact of predictive maintenance. Now there are some applications by industry, for example, railway, manufacturing, oil and gas. So railway detects problems they cause downtime for linear, fixed and mobile assets, improving safety and truck-wide detection through new vehicle cab-based monitoring. And yeah, so these are some applications by industry, manufacturing and oil gas. Yeah. So next, thanks. Any questions? Hello?
Yeah, like, would you say that the aquarium,
Aquarium?
yeah, the aquarium that's there in the, what's it called? The office, is
Mm-hmm.
that also kind of like like, does it have some predictive maintenance thingy?
We are predicting when the conditions are not. Yeah, it is a kind of predictive maintenance, but not in industrial application.
Okay. Like what is used for like the in that aquarium?
Hmm? So
Like
there
what?
are some IoT devices fit there, which IoT devices are basically some devices which communicate to them, to one each other, and um, uh, makes a complete system work. Like there are some sensors fit onto that equipment which checks the moisture in the water, whether the fish needs, like where the fish is moving. It is continuously tracking the location of the fish. Accordingly, there is a feeder connected there. So when this it like the device will detect that it is required to insert some feed from the feeder, then it launches it. So this is basically example of predictive maintenance itself. Yeah.
Basically, it's maintaining the fish.
Yeah, but predictive maintenance is done prior in time. It is in industrial application. It is not done when the machine is completely broken. So the aquarium in office, it insert the feed when it is required, not when like it will not give us the useful life of water pending in prior. I need to manually go and insert the feed. Yeah.
Okay.
Anything else?
That's it from my side.
Mm-hmm. Okay. Chalo. I'll put this PPT in AI session file section, and if you have doubts, you can call me.
Ravi,
You know.
one question.
Hmm.
We were talking about the predictive analysis, right?
Mm-hmm.
Yeah. So in predictive analysis, we were talking about the maintenance mostly. Excuse me. We're mostly talking about the predictive analysis for the
Mm-hmm.
maintenance department. So if we have to define an application for a garment industry or any manufacturing unit, because these guys have like a maintenance department completely set up, which looks at the technology, automation, and
Mm-hmm.
of whereabouts of the machine, when to change, how to change, things like that. So in those contexts, let's say that we take a industry called for manufacturing of vehicles. So in such case, can you define one specific application of it?
Manufacturing of.
Vehicle.
Yeah, so manufacturing is like, let's say the recent example which I have worked on is basically there is a plant which have some three-phase induction motors. Now I need to define predictive maintenance for that. So predictive maintenance is basically one of the application is using time series analysis. So time series analysis we have discussed before, if you remember. So what we'll do, in motors itself, I will take let's say I have a month's data, and every Thursdays will have a peak load. And from last two Thursdays, my machine is failing because my factory manufacturers, it's a new plant and they don't know that this kind of load is coming. So there will be a plot of the requirement in time, in real time. So all the points are collected in real time and they are plotted in such a way that I can predict what is happening next. So if I have a month's data, I will predict what has happened last Friday, same last week, same day, same time. What happened if I have a year data? I can predict, I can look back to the 1 year back data, and accordingly I'll take that into the consideration and predict what is happening next. So this is one of the application, like time series can be utilized.
Yeah, yeah.
Mm.
Okay.
And vehicle manufacturing plants has some manufacturing equipments. I am not sure what are the exact manufacturing equipments available there,
Yeah.
but the machines or most expensive equipments which are used there, that can be taken into the consideration. Consideration as in we need to find out what all things which are affecting that particular equipment and then plan accordingly.
Okay.
Hmm.
Yeah, I think that is something that I want to discuss.
Hmm.
Cool. Are we wrapping up the session?
Yes, yeah, if no question, then yes.
Thank you.
Thank you for joining.
Thank you. Bye bye.
Bye.
Thank you for the session.